Hey everyone, and welcome to The Explainer. Today, we're diving straight into a massive breaking development in global defense, India's highly successful test of the Rudram-2 missile. We are going to completely break down both the cutting-edge engineering and the high-stakes strategy to understand exactly why this is such a monumental leap forward. Right off the bat, I want you to imagine something. Put yourself right in the cockpit of a modern fighter jet. Now, ask yourself, how do you destroy an enemy's air defense system without ever actually entering its reach? That is the exact life-or-death tactical problem the Rudram-2 was built to solve. You literally have to take out the very weapons that are actively hunting you, and you gotta do it before they even spot you on their radar screens. So as we go through this explainer, keep that immense, high-wired challenge in the back of your mind. Okay, let's dive into this. Part 1, the Rudram-2 test, a defense milestone. So the huge news driving our analysis today is that India has successfully tested its homegrown indigenous Rudram-2 air-to-surface missile. And look, this is absolutely not just your run-of-the-mill everyday equipment check. This marks a highly significant advancement in the nation's defense capabilities. What you really need to take away here is the sheer nature of this weapon. We're talking about a long-range missile designed to be launched straight from a fighter jet mid-flight. When you're testing an air-to-surface weapon of this caliber, you are dealing with mind-boggling speeds, extreme altitudes, and insanely complex physics. Pulling this off, it signals a major leap forward for the Indian military. Moving right along to our next section, Part 2, Inside the Missile's Tech, Precision, and Power. Now, what's really interesting about this slide is the highly specific list of hostile threats this missile is built to hunt down and destroy. The Rudram-2 is basically a dedicated predator for critical ground-based threats. We're talking enemy radar installations, active air defense systems, and other high-value ground targets. Think about it. Taking out a radar installation essentially neutralizes your opponent's ability to deny you airspace before they can even get a shot off. It's blinding them. This missile acts as a high-speed silver bullet solution to the exact threats that pose the biggest danger to any modern air force. To really grasp how this tech works, we need to know exactly who built it. All of this advanced guidance technology was developed entirely by the DRDO. That's India's Defense Research and Development Organization. Knowing the creators here really gives us the right context for why this test is such a big deal. Building a long-range missile that can literally think for itself and independently seek out a hostile radar dish. That involves elite, cutting-edge engineering. The DRDO engineered this advanced guidance system from the ground up to make absolutely sure the weapon finds its mark with total pinpoint accuracy. Let's move to and see how this builds in a real-world combat scenario. When the missile leaves the jet, it has to execute 3 unbelievably complex mission objectives. First up, target acquisition. The missile's advanced guidance tech actually has to find and lock on to the hostile target. Second is navigation. It has to fly itself over vast distances, constantly correcting its course in midair. And third, precision impact. It has to physically strike that high-value ground target with devastating accuracy. Honestly, doing just one of these things is hard enough, but doing all 3 flawlessly while traveling at supersonic speeds, that is just an absolute engineering marvel. Which brings us to the actual results of this recent test. Did it work? Well, defense officials confirmed unequivocally that the trial met all of those mission objectives, every single one. Target acquisition, mid-air navigation, and that final precision impact. They were all executed perfectly. The missile performed exactly as it was designed to. And this brilliantly illustrates that the DRDO's advanced guidance technology works seamlessly under real-world conditions. It's a massive validation of years of intense research and development. Let's zoom out now to the big picture. Part 3, the strategic impact and expanding capabilities. Following the test, reports highlighted a truly game-changing capability, the ability to accurately strike targets from a safe distance. So the crucial point is that term right there, safe distance. By launching from afar, Indian Air Force pilots don't have to risk flying straight into the immediate danger zone where enemies' surface-to-air missiles can pick them off. Instead, they can launch the Rudram-2 from a sanctuary high in the sky, completely out of reach, letting the missile's advanced tech do all the highly dangerous work of penetrating enemy airspace. So why does this matter on a grand scale? Because a success like this drastically strengthens India's ability to suppress enemy air defense networks during actual combat. Look, in modern warfare, if you can suppress or destroy the enemy's air defense, you completely control the skies. It's that simple. And when you control the skies, your operational effectiveness is multiplied immensely. By blinding those hostile combat networks from miles and miles away, the Rudram-2 is fully expected to be a massive force multiplier for the entire Indian Air Force. But beyond just the battlefield tactics, there's a huge geopolitical component here too. The Rudram-2 is a fully indigenous missile. This ties directly into India's broader strategic goal of indigenous self-reliance. It's all about expanding national security using domestically developed defense tech, rather than constantly relying on foreign imports. This test is a massive win for that overarching goal. By continuing to innovate and expand its own indigenous missile capabilities, India is taking full, sovereign control over its national security, keeping it completely independent of outside supply chains. Which leaves us with a pretty fascinating final thought. With the successful testing of the Rudram-2, and as India continues to drastically expand its indigenous defense tech, how are regional air defense networks going to adapt? I mean, when one side successfully develops a high-tech weapon that can snipe radars from a totally safe distance, the other side is eventually forced to figure out a countermeasure. It is the perpetual high-stakes chess match of global military strategy. Thank you so much for joining me to break down this incredible piece of technology. Keep questioning, stay focused, and I'll see you in the next explainer.